Hi and welcome. This is Dudley Toolwright, and this is my little portion of the wedge jack assembly, originally done by Maddie down in Australia for Max Grant in the Swan Valley Machine Shop. If you haven't seen Max's channel, you definitely should check it out. He's another very generous soul like Tom Lipton that contributes a ton of information and experience to the YouTube machinist community. And for most of us like me, who's definitely a novice and trying to learn, you really need to benefit from people who have gone before that, have gone through it and have had the information handed down to them over the generations so that all that knowledge and experience gets passed on. And Max is one of those guys. He always shows you a bunch of tips and tricks every time he's doing a video, many of which I've never heard. Every time I always learn something. So it's really worthwhile to just let those guys know that we really appreciate them and that they make YouTube a better place and they make the general knowledge base in the machining community much better for everyone. So my part of this project, this is the top of this jack. This wedge jack assembly we're making is similar to the one that Maddie has a 3-part series on. And the wedge jack basically has a threaded rod that pushes against a wedge that slowly creeps up at a 20-degree angle that remains parallel to the workpiece. And so the original design makes it kind of short, and it could never support something on a Kurt vise without putting a spacer underneath it. So we've modified the design a little bit to include a spacer block specifically to get right on the base height of a Kurt vise. Because when you have long parts sticking off the end of the Kurt vise, you really want to support them. And the advantage of this kind of jack, unlike the other ones that have like a little round piece on the top, this has a broad support section on it. And so you can get more of your part supported, which we thought would be a really good idea. This original project was put together by Tom over at Hilltop Machine Works, and I thank Tom for including me in this project. I think it's going to be a lot of fun. So my parts are the adjustable wedge and the spacer block that goes underneath it to hold it up to a Kurt vise, and I will be attempting to surface grind all these parts so that we get a really good finish and a accurate height for the wedge itself. Although the goal for this jack is not to have, when the wedge is all the way down, to have it right at the Kurt vise. We're looking to have it like 5/10 thousandths under the Kurt vise so you can slide it under the part and support it. I've modified the original design also so that the original design had about 1/4 of an inch of vertical motion for the jack portion of it. And I modified it a little bit, so we're going to get about 0.5 inches, a 1/2 inch roughly, or that makes it, like 12 millimeters of motion. So this jack style does not actually have a lot of range, but it does have broad support, which is really nice. So the piece that's going to be supporting the jack face is 1/2 inch wide and 2.5 inches, 2.25 inches long. That's a pretty good support surface there. So I think that's a nice plus. One other negative about the design is that since you're pushing from the back, as you're tightening this up, it's going to want to apply force to the part to push it in that direction. So that's another reason to inspire us to grind the top of this so that there's minimal friction with the part so that it does not push the part that you're trying to support, because that could be problematic. Tom specifically chose to use 4140 pre-hardened material. And the 4140 pre-hardened material, it claims, I bought this from McMaster-Carr because none of my vendors around here have it. It claims to be about 25 Rockwell C hardness. I measured this one on my hardness checker and it comes out to about 20. So it's right in the ballpark, I guess. This should be hard enough that it won't wear too quickly and at the same time won't be so hard as to not be able to machine it at all. So I got to make the wedge assembly and the spacer block. So we're just going to get started, and I'm going to start dimensioning some stock here. And I'll show a tiny bit of that only because I'm really curious about how difficult it is to work with material that's hardened like this at Rockwell 25. All right, so I've got to dimension this stock, and here's an interesting thing. I bought this from McMaster-Carr, and it's Blanchard ground. You can probably see the Blanchard grinding marks on here. And the interesting thing about it is that the Blanchard grinding was incredibly accurate. I took my micrometer and measured a bunch of points, and the thickness is consistent within like 1/10 of an inch. a 10,000th of an inch, a 10,000th of an inch across the whole space, which is pretty freaking amazing. It wasn't that much more expensive than the regular stuff. It's also over thick. The thickness is high, and the reason for that is that I'm going to need to grind it down to get it to fit that slot very carefully, that for the part that's Tom's making, the body of this thing. And not only that, was around a ½ inch. He said it went a little bit over. So I've got 40 thousandths of material here to work with, so that'll be very useful when it comes to that part. But since these sides are so parallel, I'm just going to come around, mill this side flat, rotate 90, mill flat, and then start going for dimensions on the other two sides, because it should be nice and square, and I'll have surfaces that are both perpendicular and also mutually perpendicular to the planes of the faces. So that should be really good. I was just kind of curious if the burrs were remaining, or because it wasn't cutting all the way, but I'm well into the cutting portion of this end mill. So that just must be turning up a burr and them sticking to the burr. So now I'm not changing X at all, and I'm just running over the same part a couple of times, like you can see here. And if it still removes material, it's because something's flexing and it's coming back and cutting again. Which is really interesting. I really didn't expect this behavior. That's something like 5 passes and we are still removing material. I gotta say, that's surprising to me. All right, so we got the block loaded here, and we're gonna try and rough out the center section here, which is the relief. And I'm going down 240 thousandths, leaves me 10 thousandths to remove. And this is a 3/4 inch end mill. And so we're just gonna try and take the whole thing in one bite, but very slowly, and see how it handles it. This hardened material may be tough for it. We'll see. We're at 250 RPMs. Oh, it actually seems to be going just fine. You notice I have this in a Weldon flat end mill holder. That's because I'm a bit concerned about the end mill pushing up or sucking down and cutting a knot even on the bottom, because I want it to be fairly close. So. Alrighty, so 1.222 from 1.250, so we're actually 27 thousandths under right now. So I want to be a bit closer than that before I cut my relief, so that the relief ends up in the right spot. So I'm going to switch from this roughing end mill to a finishing end mill, and just take a bit off each side. All right, so next up, I want to relieve the inside corner of both of these so that the piece can sit flat here. And in order to do that, I'm just going to cut a 45 slot in each one of these sides. So to do that, I'm using the Tom Lipton inspired 45 vise adapters. And what I did was the 1/2 inch 13 cap head screws, I drilled and tapped for 1032. And all I have to do is just screw these guys in to get the two jaw faces lined up with each other. That's where these pins come into play. Alright, so we're just going to try on the second side a full depth of cut, see if it works. It may be a bit aggressive, we'll go slowly. I'm not quite sure why this arbor is out of round. That's quite a bit of run out. So I don't know if you can see the relief, but that's going to help make grinding a lot easier. Had to space the block up, otherwise the arbor was going to run into it, but I don't know if you can see this. Need to clean this up, but there's the relief I put in both sides all the way through. And then when I grind the bottom, I can come close to the edge and get the whole bottom at one time, which will be nice. There's going to be a drilled through hole here with the relief on the other side, but I'm actually going to wait till I get the part in my hand from Tom and make sure that there's no issues with it fitting. So we're going to wait and get it, and then we'll see what we can do.